Alright guys, so I'm picking up right where I left off. Like in class, we were looking at these notes here underneath equilateral. And we kind of said because all the sides were the same, we could pick any two and set them equal. And so I picked the easiest two. But I do want to just show you, like, I could have picked these top two, so like 4x minus 6 equals 2x plus 4, and gotten the same thing. So like I would subtract the 2x, add the 6, and get 2x equals 10, and then divide, and so I still get 5. So I just wanted to show you, like, either way, you get the right answer. Okay? So then, if we're moving up, we could take a look at our obtuse and isosceles. So open this up. I know that this here should be obtuse, and I can tell because these two are so small. But if I wanted to solve for x, I feel like I would just do the triangle sum theorem, where I add up all the angles and set it equal to 180. I'd combine some like terms, and then subtract to get x alone. So x is 135, which is obtuse, so that makes sense. The other thing to think about down here too, this would be scalene, because this angle up here would be 35 degrees, and this one down here would be 55. So that's kind of fun fact. Also, there's the bell. Get to class on time. If we're isosceles, then that means two sides and two angles are the same. Okay, so if I look here, they're showing me that I have these two sides that are the same, and so I should just set them equal. So x plus 15 equals 4x minus 5. Then I would get my x's together, so I'd subtract the x on both sides. And since x will be over here, I'm going to add the 5 to get it out of there. So we'll have 20 equals 3x. And then I would divide by 3. And so x is going to be this nasty fraction here, 20 over 3. Now the other interesting thing too, though, is let's say, for instance, I knew that this top angle was 30 degrees. I could find the bottom angle or the bottom two angles, because I know they have to be the same. And so if I think about the triangle sum theorem, I know it adds up to equal 180, and so I can take off the 30 that I already know that I have. So I have 150 left. And then if I split that in half, then each of these would have to be 75 degrees. So that's kind of fun fact. Okay, last but not least, at the top we have our acute and scalene. So if we look at the acute side, we're hoping that all these angles are going to be acute, but I'm just going to use the triangle sum theorem again. So like x plus 15 plus x plus 65 equals 180. I would combine my like terms, so I'd have 2x plus 80 equals 180. I'd subtract that 80, so 100, and then divide by 2, so 50. And if I take it and plug it back in, I can see that this angle here will be 50, which is also acute. And when I plug it in right here, this one will be 75, so also acute. Now the last one that I have is kind of interesting. So it's scalene, which means that all the sides are different, so I can't really set any of them equal to each other. But it tells me that the perimeter is 30. And so I find perimeter by adding up all the sides, and so I'd have x plus 6x plus 8x. And since they're telling me that the perimeter is 30, I'm going to set it equal to 30. So when I combine like terms here, I'm going to have 15x, and so x is 2. Then I could find each side. Like this one would be 2 units long, 12 units long, and then 16 units long. Okay, so that's if we had like triangles on just plain old paper. But sometimes what I might have are triangles on graph paper. And so we also need to take a look at that and what happens when I have to graph. So if I were to classify this triangle here, and let me zoom in a bit, I would first want to plot the points. So A is at 0, 0, B is at 3, 3, and C is at negative 3, 3. And I can connect the dots. And if I want to know if I am scalene, isosceles, or equilateral, then I need to know about the sides. If I want to know if I'm acute, obtuse, or right, then I need to know about the angles. And if I'm in a grid space like this, the only angle that I can know is a right angle. So really we're just going to answer the question right or not. And I feel like I might know that I'm a right angle or not if I am perpendicular or not. Because I know that I'm perpendicular when I know the slope. So I'm going to find the slope of AC, CB, and BA, so I can tell if I'm right or not, or perpendicular or not. So the slope of AC, I'm just going to count. It's like down 3 over 3. So negative 3 over 3, which is negative 1. The slope of CB is I'm rising 0 and I'm running 6. And 0 over 6 is just 0. The slope of BA is up 3 over positive 3, which is 1. And so if slopes are opposite and reciprocals of each other, then they're perpendicular, and so it is right. So yes, they are. So right it is. Okay. The other thing I need to determine, though, is if I'm scalene, isosceles, or equilateral. So in that case, scalene, iso, or equa, I need to find the length or the distance of each of those. So AC, CB, and BA. And the only one of those that's easy is this horizontal one right here, because I can just count that it's 6 units long. The way that I found it when I was not horizontal was, if you remember, we used the slope triangle right there. So this was 3 and 3, and we did a Pythagorean theorem thing. So we did like 3 squared plus 3 squared, which is 9 plus 9, and then we took the square root of that, so square root of 18, which I don't know, so I'm just going to leave it like that. Now for BA, I think my slope was the same. It was 3 and 3 on either side. So if I do 3 squared plus 3 squared again, I think I'm just going to be the square root of 18 again. So I can tell that AC and BA are the same, so I'm isosceles. So I might just leave it there, but I do want to make some notes right here, and then I probably want to try to with you tomorrow. So we're going to find the length of sides by using distance, which, depending, I might be able to just count if I'm horizontal or vertical. I can just like count how long they are. But I might have to do a squared plus b squared equals c squared, or I think we called it rise squared plus run squared and then we square rooted the whole thing. So that'll get me the distance, and that will help me know if I am scalene, isosceles, or equilateral. The only type of angle classification that we can get on a grid is if I'm right or not, and we do that by using slope, which is just rise over run, and if they are opposite and reciprocal, then they're perpendicular, so right. And again, opposite reciprocal would be something like if I'm 2 over 3 and negative 3 over 2, those would be opposite reciprocals of each other. So guys, the bottom half of those notes we'll fill out together in class tomorrow. Just get this stuff done for now.